Well, good afternoon and welcome to the DDN booth. I am Paul Mano at Georgia's Institute of Technology. That is not the University of Georgia, for those of you who are wondering what she introduced. That is our rival school. So anyway, what I'm going to talk about today is a little bit about the storage architecture for what Georgia Tech has done for their storage in their cluster operations. So really, there's a couple different things. It's not as cool as the solution as our friends at Michigan did, but there's really several different kinds of storage that you do have to deal with. And one of the nice things about it is the folks here at this booth can actually deal with all of these kinds of things. So one of the things is distributed parallel file system. This is where you're going to get the highest performance. It's going to get reliable performance. It's going to give you robust architecture. It's going to give you what you really need to run those really high performance cluster operations. There's also basically POSIX storage. That's sort of the traditional Unix, Linux kinds of storage models. They can be highly available, and there's lots of different ways of doing that kind of a service. There's also object storage. You can have reliability through replication with objects, and there's a lot of people who have said, well, how does that fit in with the POSIX world? So we're going to talk a little bit about that as well. So it's storage tiers. One of the kinds of things that you want to look at is how are you going to use this storage? Are you going to do this with a software repository? Yes, come on in, please, and sit down. And they give away great prizes. I don't. That's the nice thing about it. I can't do that. I'm a Georgia Tech guy. So the software repository, generally off, that's kind of a read-only kind of a thing for storage everywhere. There's infrastructure storage, there's home directory storage, there's project storage, there's controlled unclassified information, CUI kinds of things, there's scratch temporary use, there's publicly accessible, there's science team, there's all these different kinds of storage tiers out there that you really have to worry about. And how do you go about figuring out what kinds of architectures and what types of pieces you're going to use for supporting each one of these? You also have some kind of distribution issues. You want to look at where does this storage need to be used? What kind of accesses does that really need to have? So you're going to end up with some storage on every single compute and utility node in the cluster, and then you've got some storage which is going to be restricted to certain areas of other parts of the cluster. So a distributed parallel file system, that's what GPFS, Lustre, those kinds of things. The company here supports all of those things. It is a really nice, sophisticated, full-featured file system, and by the fact that it is distributed and parallel, gets you the best performances that you can for that. A couple of things that it provides you, there's Lustre, there's BGFS, there's all these fine things, but they're all distributed and fully parallel. That means that every client, every system that's out there can actually participate in providing you that same storage information. So that when you request a file, that file can come from any of the machines or all of those machines all at the same time in parallel. Very much high performance actually for that. It also supports large and small data use. Folks from Michigan were just talking about the fact that they had probably 90% of their files were I think they said 1 KB or smaller, or maybe it was 1 megabyte and smaller. It was fairly small. And they said, well, how are we going to do this? And so you have to worry about these things. The storage server and the network requirements, you're going to end up with maybe hundreds of petabytes of storage. If you talk to any research institution out there, they're all doing the same thing. Their storage requirements are growing substantially, and this is going to be the same. So you need fast, reliable, accurate networks. If you're going to support this kind of a parallel file system, you've got to have a fast, reliable, very clean network. If you don't, this doesn't work so well. So, DDN provides some excellent supported options. We'll leave it to you to talk with those fine folks, and they'll help you out, I'm sure. But this scales to very, very large clusters. Things like Blue Waters have used GPFS. The new ones, Attack, are all using these parallel file systems. They're all really the common thing to do. POSIX storage-wise is fairly well-known and mature. If you have used a Unix system or a Linux system anytime, I'm sure you have used a standard POSIX file system. The interesting thing is it's surprisingly useful for a cluster. For example, distribution of a software repository. One of the things that's common for POSIX is using NFS. Well, NFS, as it turns out, has various kinds of caching that it does, both on the server and on the client, which is exactly what you need for doing things like distribution of software. Virtual machine image storage, NFS is great for that as well. Home directories, that works out fine as well, because you don't really need super high performance for how to access the files with an editor, right? The other options are you can get POSIX storage with very high availability, and it's going to be distributed around, so you can actually have multiple ways of doing that. But you can also do this with things like GPFS or by using their protocol nodes. And those are things which basically tie GPFS, the high performance parallel file system, into something a little bit more that's more POSIX oriented like this. There's also object storage. And object storage is oftentimes used in clouds, or it's on-premise, or it might be in public cloud. You can have object-based file systems. It's a lot of times you could use it for archive storage or native objects. Or why would you want to use object-based storage with a cluster? Well, there's a lot of metadata that people want to keep track of when they start looking at these files. So where did the file come from? What produced that information? All of that metadata can be tagged into each individual object and carried with that file, so that provides you some good things. So why objects? Well, there's automatic replication and retrieval, so that if you have multiple systems, you have multiple places where that object exists. If one of those systems goes down, nobody notices from the users, because there are replications of that object in other places. And the object system says, well, I'll just go get it from one of the other copies that I know exist. They can be in the same data center, they could be across the campus, they could be across town, they could be across the US. It doesn't really matter so much as how you do that. With lots of rich metadata, as I said, it can be fairly inexpensive depending on how you organize that and what products you use. So, things that you can do with objects. Distributed storage, as I said, you can do this with multiple data centers, which means if you have a power problem in a data center, heaven forbid, this does happen on college campuses, I can tell you from personal experience, you still have the ability to access all of those same objects in the same system, completely transparent to the user. They don't really notice that there's anything that's gone wrong. Meanwhile, people are scurrying, say, what happened to the power, and you get things back up, the system resynchronizes itself, it's great. So the other thing is geographic diversity. That is when you have a storm that hits a particular part of the world and you need those files somewhere else. Objects can do that for you. Intelligent data management, it gives you the speed and security of access, and you can use it for archive storage. And why archive storage? Well, archiving is becoming very much more important to all of the institutions out there. The DOE is requiring it, the NSF is requiring it. People are going to need to keep track of this information for some long period of time. It doesn't need to be super fast. A lot of people, like the folks at Oklahoma, have done so with tape drives. You can do it with tape systems. You can do it with spinning disks. You can do it with all kinds of different types of technology. But it's all basic archive. And the real catch is, how do you do this with a reasonable configuration and doing it with a very cost-effective way to do it? Well, at Georgia Tech, one of the things that we have done is we've come up with a way of doing this was a little bit more interesting, a little bit out of the box kind of thing. So we have a Globus server, which is very common. If you've been using Exceed for any length of time, you have seen Globus. It's a standard product. It's available for everybody else out there. There's an NFS client underneath that, and what that does is it talks ultimately to an NFS storage system that's out there. That NFS storage system, it doesn't really matter so much what that is. That could be something that you put together, that could be a product, that could be an appliance, whatever that needs to be is fine. What sits in between those two physically is a hierarchical storage manager. And I call that an HSM. There are multiple products that you can use. We chose a particular one at Georgia Tech. But effectively what that does is it watches that NFS storage, and every time you read or write files to that, it actually does two things for you. One is it caches all of the metadata for that. It's been very common. The other thing is that it does is it keeps track of where is that information right now. And through policies, you can actually have that HSM device move the file to other types of file systems. In our case, we said, let's do this to object storage. In our case, we had an object storage subsystem already on campus. It's across multiple departments, across multiple units and multiple buildings. That object system was still there, and we said, hey, why not use that? So what the HSM can do is it takes a file off of the NFS and moves it into the object space, again, completely transparent to the user. The user still accesses the file from the same path name that they were using before, but all of a sudden now it's off onto a different tier of storage, Maybe it's a little bit slower, but not that much. We actually see about 60 megabytes per second when it's being pulled off of the object space storage. The nice thing about that is it frees up some manifest storage, which is a little bit more expensive, and you can now utilize the SwiftStack or object space or WAS or whatever you want to have out there. It could be Ceph, any of the object systems you'd like, and that's just fine. It could be S3. You could actually have that go out to the public cloud if you'd like that. So lots of different options for that HSM as to how that does it. So how do you support all of these kinds of architectures? Well, number one, and I can't really emphasize it enough, you've got to have clean, fast networks. They really need to be something like InfiniBand or OmniPath, any of those kinds of things that are there to support RDMA. That really does help. 40 gigabit and up is really good for these high performance file systems. You need some good support people, or you need a good support contract, or both. Yeah, don't underscore that one too many times. It's very, very important. Replication versus archive versus backup. The difference between those is replication is you've got multiple copies of the same exact thing. If you delete that same exact thing, it's deleted everywhere. It's in replication. Archive says I've got a version out there someplace, and it needs to be on inexpensive storage, but hey, I don't really care how fast I can get to it, it just needs to be there. And then, of course, backup generally implies that you really want to have some amount of storage over time. You need to go back and find a file that maybe I deleted that 2 weeks ago. I need to go back and get that file now. That's a backup kind of a solution. So lots of different ways to do it. You need to look at why do you need it, how many versions do you need, how fast of a retrieval do you need. Those are the kinds of questions you need to have and answer for dealing with that. So with that, there's lots to consider. It's a very short talk, and so I think I'm fairly short here on time. I'm doing great. Perfect.
Thank you so much.
So thank you very much. I appreciate it. And ask questions. I'll be around for a few.